Okay, well today what we're going to do is we're going to continue our look at some graphs, and we're going to talk about some graphs of basic functions. Hopefully I've learned enough about the interface here to be able to come back and forth to the textbook, etc. We'll see. So we're going to look at today some graphs of basic functions, and the first thing I want to talk about is the graphs that we were looking at last time. They were all lines that were continuous, and you've heard the word continuous before. Continuous just means it doesn't stop or start anywhere. Just kind of goes on. So the easiest way to tell that a graph is continuous is that when you draw it, you don't ever pick up your pencil. So you're just drawing a line, right? It doesn't have to be straight. It can be curved. It can be any kind of line. So what we're going to look at today, one of the things we're going to look at is we're going to look at some other graphs that are continuous, some graphs of some other functions, and then we're going to look at some that are discontinuous, or that are there's another word for it, and we'll get to it in just a minute and put it in your definitions for you. But continuous means that you never pick up your pencil, you just continue to draw it. I want to try to go back to your homework so that you can see this, see some other things that you might not have realized about working with this course. And one of them is the help area and viewing the textbook. So I want to go back to the textbook so we can make sure we're hitting every detail, and that you'll also know where to go back and look at it. One thing I hesitate about using the textbook is, of course, they're going to use very formal mathematical language, but you're going to see that this text many times tries to break it down into language that's easy to understand. So let me switch over from this, go to the textbook, and see what we can come up with. Okay, so here is the homework that you'll be doing in this particular section. And you see that they're going to be asking you about graphs, and then they're going to be asking you if it's increasing. They'll also ask about decreasing. Remember that that's as you're reading it from the left to the right, just like you're reading words on a page. If it's going up, it's increasing. If it's going down, it's decreasing. But what I wanted to show you is something in your question, help. You're going to see lots of different things here. For example, usually it'll say, help me solve this, view an example, or there may be a video to watch here. But in this one, they don't think you need any of those advanced aids, but they do give you the textbook. And that's where we're going to go so that I can introduce this idea of graphs of basic functions. Because what happens is, if you can recognize the function, then you're going to be able to recognize its graph. So you'll know you'll know what the graph is supposed to look like. Okay, so let's go back to our page that we were writing on. Maybe we won't. Okay, I think I figured it out. Sorry, bear with me. So, every function has a basic graph. Now, if it doesn't, then it's not a function. But we're not worried about that right now. What we're going to do is we're going to explore what those basic graphs look like. And we're going to go to the textbook function of that and talk about these. So the basic graph or shape. So in other words, what kind of line would you get and where would it be if you were going to graph this? Now, the reason why that's so important is because if you already know what the graph is supposed to look like, then it's easy to make sure you get the graph that you need, right? So say, for example, you were going to go somewhere. If you go somewhere that you've been over and over and over and over, you know the route, so you don't have to think about it as much, right? And in mathematics, when things start building on each other and building on each other, then that's when students start getting a little lost. And so if you already know what the shape is supposed to be, then it's very easy for you to make sure that the mathematics you did that gives you the graph is correct. Okay? Because we are going to be graphing some of these. And so if you don't know them, so you need to be careful. If you do the math and you get the wrong shape, then you'll have a kind of check. Okay? So let's look at some. So here we are at our homework, and they're going to asking you which one is the graph of f of x. Remember that f of x business simply means simply means that it's a function, and you may or may not remember that specific symbol there, but that's the absolute value bars. And so the equation here, or the function, is what is the graph of the absolute value of x. So you're going to see these definitions there. So what I want to do is I want to go to this textbook help. Okay. All right, and it might take a little bit of time to come up for you. Bear with me. If you see me doing it, then you'll know this is what should be happening with you. All right, so here's where this chapter 2.6 begins, with graphs of basic functions. And the first thing I was talking about was that continuity. A function is continuous over an interval right? It's continuous over an interval if you can draw it without having to lift the pencil from the page. Okay? All right. So we've seen that definition and we've given it to you. What we're going to do now is we're going to look at some different kinds of functions so that you can be able to then do your homework. Okay, continuing to look at the textbook, we see the next thing they talk about is what happens if a function is not continuous at any point. And that indicates that there is a discontinuity at that point. Okay? And it can be anywhere on your graph. It just depends on the functions that you're dealing with. But we'll come back to that. All right? So the first function we're going to look at is one called the identity function. And the identity function, remember, if something is an identity, that means it never changes. So when you're thinking about the identity function simply says that no matter what x becomes, y is the same number. And if you look at its graph, it's always a straight line going right through that 0, 0 point. Never changes. It can't, because whatever x is, y is going to be the same thing. And again, that's called the identity function. You're going to have to be able to recognize the graph and understand that it is the identity function. Now, it is linear, meaning just a straight line, but it's not any straight line. It's a very specific one. Okay? So let's look and see what's next. Sorry, turning these pages is going to take a little time sometimes. All right. The next function that we're going to look at is the squaring function. And that's what happens when you get any function where that x is squared. Okay? And if that happens, you're going to get what's called a parabola. And that's simply that U shape. And the U shape can be anywhere on the graph, depends on the function that you're given. You can have things added to, subtracted from, and we'll look at some of that later. But it's always going to be, if it's an x squared, then it's always going to be a parabola, or that U shape. And it can either open up or down. If your x squared is positive, then it's always going to open up, like this example here. Okay? You see that in the function value that they give you, f of x is x squared, so positive. If your x squared is negative, then it's simply going to reverse it and it'll open downward. Okay? You need to know those two because they're going to ask you questions about identify the graph and then it'll have the x squared negative. That means you have to pick the one that's going down. Okay? Now, let's look at our next function that they give us. Okay? The next function that they give us is something called the cubing function, and so that happens when f of x equals x cubed. Now notice it's always been x so far, and that's very important, and we'll talk about that in just a moment because something's going to happen to you where it's not x, and so you need to be aware of that. So here cubing, remember cubing means multiplying it times itself 3 times, where squaring means multiplying it times itself twice. So with the cubing function, you always get the same graph. Now again, it doesn't, or the same shape. It doesn't have to always be in the same position. Now this one just happens to go through 0, 0. That is not always going to be the case. It can move all around the graph. But what will happen is it always changes direction right there on that x-axis, or up or down, so depending on your graph. So it's going to change direction. So the cubing function always looks like this. Now, that's again what happens when it's a positive. Okay? So, what would happen if it's a negative? It'll simply reverse it. Now, I've really exaggerated this turning point here, but you can see on the graph here that it's really, you can see it, but it's a lot more subtle than the way I've drawn it. Okay? Now notice also they give you the domain and the ranges for these. The domain and the range are always the same for these functions. The domain is from negative infinity to positive infinity. In other words, it goes forever from the left to forever from the right. The range, remember that's from the bottom up. It goes all the way from the bottom all the way to infinity up. Okay? So you'll need to know the domain and range for these types of functions as well. And they're easy to remember. Most of them are from negative infinity to positive infinity. Most of them. Okay? All right. Let's look at the next one. Okay, so the next one that they give us is something called the square root function, and then they give us the cube root function. The square root function means you're taking the square root of x. Now if you take the square root of x, what you have to remember is it's always going to be a positive. You can't have a square root that's a negative. That makes it an imaginary number, and we can't graph imaginary numbers in this field. So what we have is just, it's always got to be positive. Well, the only place where things are positive is right up here in this section. That's called quadrant 1. And so every square root function has to be going up like that, going positive like that. So let's look. Sorry. So when you're looking at these, what you'll see is that everything has to be positive. So you're always just going to get a little graph that goes up like that. Okay? All right. Now, let's look at the cubing function, and you'll see what its graph looks like. Okay? So if you look at the cube root function, not the cubing, but the cube root, okay? So that'll be, to indicate that it's a cube root, they have to put the little 3 there, right? You'll see that it looks like the cubing function, except that it's not going up and down like the cubing function did. Instead, it's going sideways. So it's the opposite of cubing, so you get the opposite direction. So it goes sideways instead. Okay? Very easy to see. Again, have to remember them. Also, remember to be watching out for that domain and range. But in this case, again, just like earlier, it's negative infinity to positive infinity. And for most of them, that is true. Now, excuse me. So, but if you look at the domain and range of the squaring function, remember I told you it has to be positive, so look at what happens there to the domain and range. If it has to be positive, it can't be less than 0. So the domain and range don't go to negative infinity. It can't include any negatives at all. Okay? So remember that the squared can't be negative, so the range and domain can't have any negatives in it. All right, let's look at the next one. Okay. All right. So here, what we have is what's called the absolute value function. Now, the absolute value function, absolute value is represented by those two upright bars. So you have your x, so this means the absolute value of x. Absolute value of any number simply means distance. And when you're talking about a distance, distance isn't negative. Think about your ruler. If you see a ruler, you don't see any negative numbers on it. Distance is always going to be positive. No matter what direction you're traveling, you're still traveling in a positive direction. So, and you'll see the graph of this one, if you look at it, it's always going to be a V shape. So you're going to get a line going one direction, a line going the other direction. Notice that the domain is in negative infinity to positive infinity. That's because it goes from left to right, all there is. But remember that absolute value is always going to be positive. So the answer is always going to be positive. So look at the range. It has to be a positive number, which means it cannot be less than 0. Now, it can be 0, but it can't be less than 0. Notice here as well, they give you a different kind of parentheses on one end than they give you on the other. And we haven't really talked about that, but this is what's called interval notation. And what happens is that if it's a soft landing, for example, like negative infinity, positive infinity, I don't know where that is. I can't tell you where that is. So it's it's a soft landing, so just a parentheses. But 0 is a definite number, and if it's a definite number, that's going to get a bracket. The squared off one's hard ending. It never goes anywhere from there. That's where it's going to be. Okay? Now, so this is the function, or the parent graph, or if some people call it parent graph, of the absolute value function. Okay? Let's look at some more. Okay, well, let's not look at some more. Instead, what we're going to do is we're going to go to your homework and start clicking on a couple of these and making sure that you understand which one you're going to get when. Okay, so again, just looking straight at your homework. This is what you'll see. It's what I'm seeing. So here we go. So what we're going to ask to do is, which one's the graph of f of x is the absolute value of x? So the absolute value of x, and remember, absolute value can never be positive. It's that little curved line. Okay, that line that looks like that. Okay. Yeah? No. Right? We've got that one. That one is actually the squaring function. We have a line that looks like this. That one is the cubing function, right? So think about the different shapes that we have. And the one when we have the absolute value is that it always goes up on both sides. So it's going to be a V shape. So if you look here, the V shape is A. So click on A and then move on. Let me check that out of writing mode so that I can click on it, so we can continue to the next part. Always remember to check your answers. Remember that you're going to get several chances every time you do that. Okay? And then they give you a separate part of this question. The second part is, on what open interval is it increasing? So increasing means going up. So look at your graph. Now, any of these graphs can be made bigger by simply zooming in, and you can zoom in again to make it bigger and bigger, or you can pop it out, which means you get to see the whole page just with that graph. So make sure you're utilizing the features within MyMathLab to make sure it's easy for you to see, okay? So they even give you a couple of the points on there to show you what they would be. If x is this, then what would y be? Now, so remember, increasing means you're walking along the function from this direction, right? So if I hit the function here at this direction, I'm not increasing, I'm going downhill, so that's actually decreasing. I don't start increasing until I get right there, and that's when it starts to increase. At that point, right in the center, is where the graph equals 0. Now, then it increases forever. So it's going to go forever to the right, which indicates that it's going to be a positive infinity. But I want proper interval notation here, and proper interval notation, because this is a hard stop, a number, is going to give me a bracket, but this one is just going to be a plain soft parentheses because I have no idea where positive infinity is, so I can't stop it there. Okay? So we will type in our answer. And here you have your symbols that you're going to need down here. May have just steered wrong. So let's put it in as an ordered pair and see how that works. 0 and positive infinity. Check our answer. You'll see that it tells us that we're okay on the previous step, but we're not okay here. Excuse me. And that's because of that 0. So let's see if we can't fix that. Oh, well, it wasn't because of the 0. It's because I left a space in it. Okay, well, at least you get to see me making mistakes. So when you make mistakes, don't feel bad about them. I do it all the time. So when you're doing that interval notation, we're just going to be using plain parentheses on everything. But when you're doing the domain and range, you're going to be using the other types of parentheses. You'll see them in the questions, and we'll live and learn together as we go. Don't hate me. It's just the way it works. Okay. So look at our next question. Again, these are multiple choice. All you have to do, the main part is the second part of the question. Which one is the graph of f of x equals x to the third? Remember, that's the cubing function, right? Now the cubing function means that we're going to get something that looks like that. So all we have to do is find the graph that looks like that, and it doesn't, looks pretty much like it's got to be f, right? So let's click on it and see if that works for us, right? So you're just picking the right graph. Now, we want to do the range. Now, remember, the range here means how much it goes from the bottom up. It goes everywhere to the bottom, everywhere to the top. So our range is going to be from minus infinity to, so that's what I didn't do last time, is I didn't tab to the box. I'm in the box to positive infinity. And check your answer. Whoops, again, I didn't click on it right. So finally, I got all my clicking right, and you'll see the range from negative infinity to positive infinity. You'll be using these clicking functions a lot more than I do, so you'll be a lot better at them, I hope. Okay, let's see what's next. Again, you're just looking at functions and graphs. This one they ask you which one is not the graph of a function. And remember, we looked at that last time. We can tell that we can use that vertical line test to see if something is a function. And if you look here and start drawing vertical lines, we can't hit this more than once, or this one. But if you draw a vertical line through this one, it's clearly going to hit the graph more than one time. So it hits, for example, I could hit it there and there if I'm drawing this vertical line. And that happens all over the place. It doesn't really matter. If you can do it once, then it's not a function. Make sure that you're checking them all, but if you look at the rest of them, none of the others do that, so clearly there's your function. Okay? Now, for this one, what they want to know the equation using x and y as the variable. Well, this one is not a function because of the way it goes, but if you look at the shape that you're given, the shape that you're given looks like a parabola, except that it's a parabola going sideways. Okay? So, look at the equation when that happens. It's not a function, so you're not going to get f of x. Instead, you get x equals, and since it's a parabola, that U-shaped thing, I'm not writing around the E, I'm just writing a U-shape. It's a parabola opening to the right. That tells you that it's not an x squared, but a y squared. And since it's opening to the right, that's where things are positive. So if you've got a shape like this, where it's opening to the left, it would be the same type of equation. That means it's not an x equation, it's a y equation, but it would be a negative y squared. So the same shape occurs even when you're talking about things that aren't functions. In other words, things that are not x functions, you're talking about the y values. Okay? So make sure you know that different shapes, right? Know the shapes of the functions, and then when they're not those shapes, it's easy to tell what they should be. So let's continue our look. Just going to go through our homework. Which one is the identity function? Remember, identity function is a straight line that goes right through. Whoops, I've left it on show complete answer. I don't want that. So the only one, and you notice if you change it again, the only one that does that is this straight line going through the zeros here. So in this case, D. Okay. And remember that the identity function, x is always equal to y. So if you look at the equation of that, x is equal to f of x. So anytime you do the function, you're going to get exactly the same number. So x is equal to whatever x started out to be. All right? Memorize that function. Also remember that its domain and range are negative infinity to positive infinity. Okay? All right, let's see what's next. The next one they give you is a cubed function, but a cubed root, right? So all that does is lay the cubed function on its side, okay? And they ask you, is there any interval over which the function is decreasing or going down? And so if you look at the graph to see if it's decreasing, as you see the graph, remember you're coming from this direction, reading it from left to right. It's going up here, it's going up there, it's always going up. If it's always going up, then it never decreases, it only increases. So you can see that remember to go from the left to the right so you can determine increasing and decreasing. Okay? Again, make the graphs bigger so that you can see better. Right? Which one is the graph of f of x equals the square root of x? The square root of x, again, sorry about that, I don't want to show you the answers first. Square root function is that little thing starting at 0 and it's half a parabola. So there we go. No, it's a, right? Starts at 0 and then zips up. And they want us to determine the domain in interval notation. So here we go. So looking at domain, we're going to type in our ordered pair, and the domain does not, right? Domain means look at it from left to right. It doesn't even exist over here, so there are no negatives. So that means it doesn't even start existing until 0, and then it goes from there all the way to infinity. And I'm just going to click on check the answer because I can't seem to make these things click right. So you'll have to. Let me just show you the completed answer. So there you see from 0 to infinity. And again, because it's a hard stop, they give you the 0 with the bracket instead of the parentheses. Okay? Let's see. Alright. Now they want you to just determine which graph is discontinuous at many points and what is its range. So looking at discontinuous, that means that you can't just put your pencil down and draw the whole thing. And so looking at these graphs, here, down, up, up, even though it's sideways, doesn't matter, still one long continuous line. The only one that's not continuous is this one. It starts and stops, starts and stops. So you see that you couldn't draw this one with one pencil stroke. Okay? And they want you to determine its range. Now remember, range is where is the graph as it goes from the bottom up. And if you see that this thing continues all the way down forever, so it starts out way down here at negative infinity, but it doesn't exist everywhere, right? It doesn't exist between these. It's only existing when you're on these lines. So in other words, it only exists where y's are actual whole numbers or integers. So they have to be negative or positive numbers. It doesn't include any fractions or decimals here, right? So it doesn't exist everywhere. It certainly doesn't start at 0 because there's stuff down here, right? So it can't be starting at 0. Instead, what's happening is it's just using integers. This is called the integer function, by the way. So -3, -2, -1, etc. So if you can use my math lab to eliminate something, and we're going to rely heavily on that later, then it's a lot easier to determine sometimes which one is not the right answer to get you to the correct answer. Okay. Which graphs of functions decrease over part of the domain and then increase over the rest? And in what open intervals do they increase or decrease? So increase and decrease, remember? So which graphs decrease over part and increase over the other? That means there's change, right? Here, if you look at this one, it only goes up. No change. Here, only up. Only up. But if you look at this one, down and then up. So that one does decrease, then increase. Decrease, then increase. So they want you to select all that apply. This one, always up. If you can't tell, make sure that you draw, that you expand it so that you can really see. This one, this one, it's crazy, right? This one's discontinuous, but it's not the graph of a function at all, so who cares? This one, look and see what it's doing. It's not the graph of a function. It's going up and it's going down, but that's not an increase or a decrease over a period of time. So let's look and see if we got them all, right? So these two weren't even functions. So make sure you look. Which graphs of functions, right? Okay. Now, looking at those, and they tell you now which ones they were, think about which ones, where they, to the graph, where do they increase and decrease? So looking at, they're typed in because, you know, I can't type these in for some reason. What difference does it to the right? Sorry, I think it'd be this one. So what does it increase? Well, it doesn't start increasing until right there, which is at 0, and then it goes up from there forever, right? 0, okay? So, again, you're not talking about domain or range, so don't type in the, so we're just talking about some space on the graph. So that's why you're just getting parentheses. Otherwise, you'd get brackets right by the 0. Increase starts at 0 and then increases from that point. Okay. Decrease, well, it decreases forever to the left, but it stops decreasing right here in the middle, which is 0. Okay. So you'll have to be able to tell where and when. Okay. Let's see. Determine the intervals of the domain over which the function is continuous. Well, can you draw this line without ever stopping? If you can, then it's continuous everywhere. So the function is continuous from negative infinity all the way to positive infinity. Okay? I'll show you how they type that in. All the way from negative infinity to positive infinity. Okay. Okay. Determine the intervals of the domain over which the function is continuous. Well, it starts right here and then goes up on forever, right? So we can draw it with one line, so we know that it's continuous wherever it exists, right? But if you look, it doesn't exist everywhere, does it? So, looking at our graph, you'll see that it doesn't even start until you get to this point. So, when you're determining where it's continuous, it doesn't even start existing until x equals 3, right? As you're going from the left to the right, you get to x equals 3 first. Then it starts moving forward. So it doesn't even exist. So that's going to give you that hard stop, where it doesn't exist. So it doesn't even start existing until 3, but then it does just go up forever, and that means, or go on forever to the right, I'm sorry, which means positive infinity. Okay? So be careful about functions that don't exist in certain areas. It is continuous, though, because it moves on. All right. Now we're going to change our tune a little bit here, and we're going to look at some functions that are called piecewise. Now these functions are discontinuous functions. And so what we're going to do is, when we're talking about piecewise, you have to just think about what that means. It means you're going to have a piece of a graph. So just think of it as meaning in pieces. Okay? So you're going to graph more than one function on the same graph. Okay? Now this freaks students out, and it shouldn't, because it's very easy. You're not going to be doing anything unusual here. You're just going to be plugging in a number and doing the math to find out what the number would give you if you what the function would give you if you plug that number in there. Now they are going to give you some restrictions though. And if you look at this area, these are your restrictions. For example, these are the inequality symbols, if you might remember those. So it's telling you that this one, x is less than, remember, less than is the one where you get to the point first, you get to the small part first, that means less than. But it also has that little line underneath it, which is the equal symbol. So that means is less than or equal to -2. What that tells you is x can be -2, or if it's less than, right, x can be -2 or smaller. But the key there, part of that is it can be -2, and that's because of this little equal part right there. Well, that didn't work out very well. Let's get rid of that. So that little equal part, it tells you that it can be that number. Look at this at the bottom one here. We have x is greater than -2. That means all of my x's can only be larger than negative 2. Can't be smaller than negative 2 because that says x is bigger than negative 2. So x is bigger than negative 2. Now notice this time there is no line underneath it like that. So that means that it can't be negative 2. Okay? Now when that happens, you're going to get different symbols on the graph when you're drawing these lines. Since they have definite starts and end points, you're going to get some different symbols on the graph. So anytime you see this equals part here, what you're going to get is a dot on the graph. Okay? Anytime you see one of these symbols that doesn't have it, what you're going to get is you're going to get an open circle. And you can call it an open circle. I don't know why they call it that. It's just a circle. That tells you that the graph starts there, but it doesn't include that point. That's just a boundary point. Okay? Now, let me get rid of all this writing off of here so that we can look at this actual problem and see how to work it. Okay? Let's erase all of those. So, it says, for the piecewise linear function, find, and then they give you f of all these numbers. Now, we've done that before. That simply means plug the number in and do the math. But if you look, we have two functions here. We have 2x as one of our functions, and then we have x minus 2 as our other function. So we're going to have to do it for all of those points, right? When it's appropriate. Okay, so if f is negative 4, for our first function, 2, replacing x of negative 4, just means 2 times negative 4, which is negative 8, right? And you're going to continue to do that with all of those numbers for this particular function first. Let's do all of those numbers with that. So the next one would be 2. Our next function value is negative 2. So that gives us negative 4. Again, your calculator can do that. Make sure you utilize that calculator a lot because they may give you some fractions here. Okay, so you see it matches what they give us as our answers. We already have our answers down here, so we can make sure that I do it right. Then we get 2, so f of 0 is the next one, times 0, which gives you 0. Okay, then we get 2, so they switch to the other function for that one. Which I'm not sure why. Hold on, let me check. Well, because I'm not a very good person, I'll tell you. Okay, let me show you why they switched to the other function for that. 2 times 0 equals 0, but what does this, so that says that x has to be less than or equal to 0, so we have to reject that number. I'm sorry, x or less than the negative 2, because 0 is less than negative 2. So if our function gives us a value that isn't allowed, then we have to throw it out. Okay? So let's continue with that particular function. Our next thing is positive 2, so 2 times 2 is 4. But is 4 less than or equal to negative 2? Nope, so we have to get rid of it. So finally we'll do the last one. 2 times 5 equals 10. But again, our restraint here, this part, right, x has to be less than or equal to negative 2, won't allow us to have a positive 10, so we had to get rid of that one. Okay, so we find that from the first function, the only values that we're allowed to get out of all of these 5 that we had to work out, right, we had to try every one of them, but the only ones we're allowed to keep are negative 8 and negative 4. Once you've done all of those, what you're going to do next is we're going to do exactly the same thing, but this time we're going to do it with the other function. So remember, the other function is x minus 2, but remember, x has to be bigger than negative 2. It's our constraint. Alright, so plugging it in, x minus, and it's negative 4, x Notice I replaced the number and not the letter. Let's try not to do that. Okay, so it's negative 4 in place of the x, so negative 4 minus 2. Combine those, it gives you negative 6. Is negative 6 bigger than negative 2? Nope. Think of your number line. If you had a number line here, here's negative 2. Negative 6 would be way down here, which is smaller. We can't have it be smaller. This says it has to be bigger, so we have to reject that number. Do the next one is f of negative 2. So negative 2 minus 2 gives us negative 4. Okay, and negative 4 is down here, so we have to reject it. Now it's still one of our answers, but that didn't come from this function, that came from the other function. Okay, so that come from the other function value, so don't worry about that one. That you're getting the same repeat, but it's not there because you're going to do each function independently, and then we'll graph each one independently. Okay, now f of 0, 0 minus 2 equals negative 2. But remember, our constraint says that x has to be bigger than negative 2, so I'm not allowed to keep it. Okay, again, this one came from the other one. Now look at where am I there? F of 2. So 2 minus 2 equals 0. 0 is bigger than negative 2, so we get to keep it. And then finally, f of 5 gives us 5 minus 2, which is 3. And 3, of course, is bigger than 0, so we get to keep that one. So there's our last one. So we have to do each one of them in every function, but we're not allowed to keep the ones that our restraints tell us can't happen. Okay? And we have different constraints on the two different functions. So don't think that it's the same restraint on the same function, on both of them. Okay? All right. So there we are. Let's see what they do to us next. Same thing, just plugging them in, but this time instead of finding the values for two different functions, I've got three different functions here. So plug in all the numbers into this one, then plug in all the numbers into this one, then plug in all the numbers into the third one, and then after you've plugged in those numbers, though, remember these constraints, these things that x can't be. This one means that it has to be equal to or smaller than 2. This one, it's a little different. It means that it has to be between 2 and 6, right? So it has to be bigger than 2, but less than 6. So it has to be any number between 2 and 6, and it can't include 2 and 6. So anything, so it can't include those numbers, it's just anything in between those two. Right? So be very careful when you're looking at your constraints. If the x is between two numbers, that means it has to be between those two numbers. But remember, it doesn't have that little equal symbol business under here. And if it doesn't have it, then it can't include that particular number. Okay? So plug the numbers in and do the math. Pretty straightforward. Almost through. All right. Then they want you to graph the piecewise defined function. So here you'll notice that they didn't give us a bunch of numbers to plug in. So what we're going to have to do is we're going to have to choose our own numbers to be able to graph these. Now, you can also look at the graph and eliminate some of them. For example, if you look at these graphs, you're choosing the correct graph. We're going to be looking at little pieces of it. So if you had any that didn't look like they changed, then you could eliminate that one. But in this case, it's not giving us any. We can also often look at these constrictions and see if there are any constrictions on this. So that will allow us to eliminate one of them. But in this graph, the thing that makes it pretty easy is that the graph of that one is always 1. So it can't be anything other than 1. right? But it can only be 1 if it's bigger than 5. Okay? Well, if it's always 1, that means that it doesn't matter what number x is, it's always 1. So it's always going to be just up 1. But that can't happen until it gets to 5, right? So that means it doesn't start until you get to 5. Okay? All right. So be careful if it equals a particular number when you're graphing those. Those are very easy to graph, but you have to make sure you remember that makes either a horizontal line. It just makes a horizontal line. But watch that constriction. Okay? Go back and look at those videos for the how to graph in the review sections if that gives you difficulty. You might also, I'm not sure, but let's look in our question help. Yeah, there's a view and example, help me solve this, and a video on this one, so you're going to get a lot of little aids there. If I'm not giving you enough information, find it for yourself. It's definitely there. So now we wanted to look at the x minus 4, and all we really need to do is simply choose some points. If I choose some number for x, what do I get for y? Okay, and when you're doing that, what you'll do is you'll see if that number exists on the graph, and if it does, then that graph is a possibility. If it doesn't, then that graph isn't. The easiest number to choose is x equals 0. It just makes your math a lot easier. If x equals 0, you're placing that into this function, right? Make sure you're placing into the right function. That tells you that y should be negative 4. Is negative 4 less than or equal to 5? Yes. So negative 4 is definitely one of the numbers on that graph, right? So that's the point 0, negative 4, which means, remember, that means that if you were graphing it, that means you wouldn't go to the right or left any, but you would go down 4. So it would be right there. Okay? So looking at these graphs, that means it has to go through this point, right? We said that this point was on the graph, so that means it has to go through this point. So if you look at your graphs now, just looking at the graphs, this one goes down like that. This one doesn't go down to that point, so I know it can't be that one. This one doesn't go down to that point, so it can't be that one. And this one doesn't go down through that point, so it can't be that one. So it has to be A, right? So this one goes down through that point, right? So this one does. This one doesn't ever go down here. This one doesn't ever go down here, and that one doesn't go down there. So by default, it has to be that one. So sometimes all you need to do is find one point, and it'll be able to give you the information that you need to find the graph, to find out the correct graph. Multiple choice is your friend, right? Process of elimination. That's how you do so much in life. All right. Look at number 14. Here we have our two functions, right? We have our two functions and we have our constraints. This time, excuse me, we just need to be able to find out which graph is which. So we will start by just testing it. So look at our first function. We're going to try 0, right? So that gives us negative 1 minus 0. And negative 1 minus nothing is still negative 1. Our constraint is that it has to be less than 2, less than or equal to 2. Well, negative 1 is less than that. So that means that our first graph includes the point 0, negative 1. Okay? So that means, remember that if you graph that, it means you don't go right or left any, but you go down 1. Right? So that's that point right there. So any graph that includes that point is a possibility. Well, if you look at this one, let me make that bigger. If you look at the first one, here's 0, negative 1, right there. Do either of the lines hit that? no, then clearly that is not the graph we're looking for. Okay? And then you can continue that. Here, 0, -1 is down there. It's down here somewhere, so we know that we don't see it, so we know those lines don't touch it. This one, we need to look at more closely to see. So let's make it bigger. And you'll see right there that point 0, -1. So you'll see that that point 0, -1 does exist on the graph, on that particular graph. Okay? And you'll also see that same thing on the first graph. Oops, I've changed my problem by clicking on it and looking at the help me solve these things. So you have to see where the -1 exists. So it exists here on D, and it also exists on B. It doesn't exist anywhere else. Okay? So that tells us that knowing one point is not going to be enough. Okay? So instead, we're going to have to choose another point, and the other function is the easiest way to do that, to see if that point exists. So let's do the other function, our x and our y. I always choose 0 because it just makes the math easier. -5 plus 2 times 0. 2 times 0 is 0. -5 plus 0 is -5. Our constrictions are that x has to be greater than 2. Okay? So if x is greater than 2, that means that it can't be -5. So the point 0,5 can't be on our graph anywhere. Okay, so that doesn't really tell us anything. So let's go back here and work this out as an example so you can see each portion. I'm going to explain this in case they use any mathies. So we know it's a piecewise defined function, right? So we're just going to graph each function's domain separately. So your constraints will tell you where the graph ends. So in this one, it says that x is greater than or equal to 2. That means x has to be, less than or equal to 2. That means it has an endpoint of 2. Okay? Can it be 2? You bet it can be. So the endpoint is x equals 2. Okay? Alright? So we know that it ends at x equals 2 and that it ends in a solid dot. Okay? Because it can be that number. So you're just going to find some numbers that will fit into that graph, making sure that your x is bigger than -2. So we know it has an endpoint where x is 2. Okay, we know it exists, so what we'll do is we'll plug that function into the graph to find the rest of that endpoint, because remember, every point doesn't have just an x, it also has to have a y as well. So if you look at doing that, if x is 2, right, then plugging that into the function, there's our function. So -3 minus a 2. So -3 minus a 2 becomes -3 minus 2, which is -5. So there's the endpoint. It's 2, -5. And we know that endpoint exists on the graph because of that little equals portion, right? So we can plot the point 2, -5 on our graph. That means go to the right 2 and then down 5. So you'll see they've put the little blue dot where that is. And again, it's a solid dot because it exists on the graph. Okay? looking at the next portion of it so we plotted the point. We want to find another point on this part of the graph, so we substitute any other value of x in this part of the domain. So what they did was they selected -4. We know that it's got to be bigger, right, than the points. So what we're going to do is select some number that'll fit inside the domain. Okay? So if x is bigger than 2, I'm sorry, less than or equal to 2, we'll pick any number less than or equal to 2. So, and that will work. Anything within the constraints here will work. Right? So they just picked -4. You can pick any number that's less than 2. So again, if you pick -4 for our x, plug it in, -3 minus a -4 becomes -3 plus 4, right? That minus a -4 becomes a plus, which gives you, and you could put that into your calculator as long as you use your parentheses, then it'll do that for you. So make sure you're careful when how you enter it. If you're using your calculator, you're going to depend on your calculator. So that's going to give you a 1, okay, when you work that out. Okay, and you'll see that same math here on that they did in the help me solve this. All right, sometimes they're not as thorough, but in this case they were pretty thorough, except they didn't show you what happens with this minus a minus business. Okay, so I'm going to continue to do the math even though they do it as well. All right, continuing, we need to plot that point on our graph, and that's what they've done. If you look here, the point -4, 1 was what we got, so that means we're going to go to the left 4 and then up 1, and you'll see that's the point they gave us, and that line has to go through that point, so that's why they drew this straight line from there to there. So that's the first piece of this function, this piecewise function. Okay, so all you have to do is choose points that will fit within the constraints. It's pretty easy. Now, I would not have chosen -4. That's what they chose. If I can, anytime I can, I would. So here, x can be anything that's less than 2. Well, the number that's easiest to use that's less than 2 is 0. Okay, and it would be perfectly fine to use that. It would still fit on the graph. So don't think that you have to always pick negative numbers or anything else. Any number that would fit within those constraints of being less than 2 would work. Okay? They just happen to pick -4. You can choose any number you want to, because remember that this thing, other than the constraints, it's every number other than that. You could have even chosen a fraction or a decimal if you wanted to. I can't imagine why you would want to, but you could. Okay? Let's continue. Now we're going to, so we've drawn the line there, right? Now, so the next thing we need to do, the second function also has a constraint. So let's first find its endpoint. Okay. So its constraint, x is greater than 2. So what we'll do is plug it in as if x could be 2, but we'll talk about that in just a second. Oops, sorry. So x and y. So if x was 2, plugging that into our function, -9 plus 3 times 2 gives us -9 plus 6, which is -3. So we would get a y value of -3, right? Now, but notice, this thing doesn't say that it can be 2. It says it has to be greater than 2. So this point that we got is not acceptable as a point on the graph. It only gives us our end point. This is where the graph begins, but that point is not included. Okay? So look what happens when you graph that, if that's true. Okay? Click on continue. So you plug it in, you get your 3, like we just did, and you see at the point 2, -3, you get an open circle there. Okay? So remember our point that we had was 2, and we plugged that in, we got -3. So that means go to the right 2 and then down 3. And you'll see they plotted that point, but they didn't put a dot on there. They put an open circle because this point is a boundary, but it can't be included. Okay? Then they're simply going to choose any other number that's within the domain to find another point to use on the graph. And they used 4. So if you plug in 4, -9 plus 3 times 4, okay, gives you -9 plus 12, okay, which is 3. So the point they chose gave us the ordered pair 4, 3, right? All you're doing is substituting these. Go back and look at that if that's giving you some trouble. But you're just substituting values that fit. Now we have both lines plotted on our graph. Okay? And so there's the answer. And you'll notice that these could not be drawn with just one pencil stroke, so therefore they're not continuous. There you go. You're going to do the same thing here. Okay? But notice that these two lines don't have an X in them. So it doesn't matter if they're just numbers. It doesn't matter what value X is going to be. The f of X is always going to be that. Okay? So no matter what number you pick for X, the Y you're going to get, and the first one is -2. So -2, -2. So here it doesn't matter what numbers you pick. The value you get when you plug it in has to be -2. It absolutely cannot be anything other than that. Now, we still have to follow the constraints though, which says X has to be less than or equal to -2, which means that none of the numbers that I just chose are allowed, because it has to be smaller than -2. So let's look at what happens then if we choose numbers that we can pick. First of all, we know that -2 is our constraint, so we have to pick -2, but it's going to give us -2. There's no math to do. Another number less than -2, how about -1? But it doesn't matter what, because there's no X over here, so it's just a number, so it's still going to give you -2. Okay? Now the bottom one is the same way, except this time it doesn't matter what X is, Y has to be -1. And again, that's because there's no X over there to fill in to do the math. It just gives you a number. So all you really have to do is follow the constraint. It has to be bigger than -2. So -2, -1 is our boundary point, but be careful, it's not going to get a solid circle, right? It's going to get that open circle because this doesn't include that equals symbol part. It's just a boundary line. So it's going to get that open circle on the graph. And then any other number that's greater than -2, well, you want a number greater than -2. Ooh, look what I did up here. -1 is X, so -1 is less than negative. So a number greater than -2, so -1 is bigger than -2. This one wouldn't work because if this says X has to be smaller than -2, I could use -3. There you go. How convenient is that? I can just change it. Well, all right. Now, then you have enough numbers to be able to plot your points, right? And then choose the correct graph. So you see here that the boundary points for each graph, here's the graph that is the actual answer. So let's enlarge it. The first one said the boundary point was -2, -2, and it was included on the graph, so that's why they have that solid circle. And then it was everything along that line that was less than it. Then the second one, the boundary point was -2, -1, but it did not include that point, and it was everything that was bigger than that. And so there's your graph. Okay? You just have to practice these and work with doing them. And so to give you a little more practice, here's another one that has 3 lines on it. Makes no difference at all to your answer. Just graph all 3 just like the ones you did. The difference is going to be what happens in this middle one. Notice that x is between these 2 values. So that means that it starts at -4, ends at +5. It can only be numbers between those. Okay? So what's going to happen is you're going to get a line segment on those. It's not going to give you an arrow at either end. Okay? It'll just be a line segment when you graph it. Get those graphed. Make sure you know those basic parent functions, and I'll try to make your lectures shorter than this in future, but I do want you to have a chance to see every single problem worked out if it's possible. Thanks.